Hi everyone, this is Maverick Pua, the chemistry guru. Now in this video, we want to discuss the suggested solution for 2020 A-Levels H2 Chemistry Paper 1, question 15. Let us take a look at question 15. When an acid is titrated with a strong base, an equivalence point is reached when the amount of base added is equal to the amount of H plus dissociated. The curve for the titration of 50.0 cm cube of 0.10 mole per dm cube for ferric acid, a triprotic acid, against 0.10 mole per dm cube NaOH is shown. So the question actually gives us this titration curve involving your H3PO4 phosphoric acid, which already the question mentioned that this is triprotic. That means it can dissociate to give me 3 H pluses with sodium hydroxide. So by right, we do expect to have 3 equivalence points for this particular titration, but let us just focus on what the information is given inside this titration curve. So we will talk about it in a while. The table shows the pH range of color changes of some acid-base indicators. So thermal blue pH range of the color changes is given here. Our naphthol rate pH range is also given. Neutral rate, the pH range is also given. Now, some of these indicators, actually, we are not very familiar with them, but it doesn't really matter since they give us the pH range of color change, then we will just apply them accordingly. So which indicators should be used to show the first and second equivalence points? So we have 4 options A, B, C, D. Of course, we would run them through in a while. Now, the topic tested inside this question, by right, it is under ionic equilibria, more specifically titration curve. Now, effectively what we want to do is we just want to determine a suitable indicator to detect the first and second equivalence point, or to detect each of these equivalence point. So what is a suitable indicator for a particular equivalence point is when the working range of the indicator is within the range of rapid pH change at the equivalence point. What do we mean by the working range? The working range of the indicator, it is the pH range of the color change. I think it will be a lot better if we take a look at the titration curve and we try to understand this idea. The equivalence point should correspond to a region where there's a very big change in the pH of the solution. So by right, when you look at this titration curve, we should be able to tell, all right, the first equivalence point is roughly about 50.0 cm cube of NaOH added. So from this graph, we can roughly tell that because during this region at the first equivalence point, the gradient of the curve is very steep, which would mean that there's a very big change in the pH of the solution at the first equivalence point. Now the second equivalence point should be around 100 cm cube, which we roughly have this here at about 100 cm cube. The second equivalence point is again where there's a very big increase in the pH of the solution. Now what we can also do is we can try to look at the working range of each of these indicators, my thermal blue, my naphthol rate, and my neutral rate, and I try to put this inside this titration curve, and we can consider the working range or the pH range of color changes for each of these guys. Now indicator 1, my thermal blue, this is interesting. This guy actually has 2 pH range of color changes, pH 1.2 to 2.8, which I've indicated in blue here. I think if we do by color coding, it is easier for us to reference that. So thermal blue, the working range, pH 1.2 to 2.8, which is roughly here. So this is involving my thermal blue. Now thermal blue actually changes color again between pH 8 to 9.6, so which is roughly around here, around 8 to 10. So this is the working range of your thermal blue in another region, around 8 to 10. Now how about my naphthol rate? Naphthol rate, the working range is about 3.7 to 5. So 3.7 to 5 is somewhere here, around pH 4 to 5. We just need to have a rough gauge. We don't need to do this in detail, all right? So neutral rate, the working range is from 6.8 to 8. So it is around here, around pH 7 to pH 8. Again, we do by color coding. The blue region will be the working range of my thermal blue. The pink region will be the working range of my naphtha rate. Orange region will be the working range of my neutral rate. Now again, we have mentioned that the indicator will be a suitable indicator to detect that equivalence point if the working range is within the range of rapid pH change at equivalence point. Now the working range is just the pH range of the color change. The rapid pH change at equivalence point number 1, which I've highlighted in yellow, is roughly around pH 3 to pH 6. We don't need to determine this very accurately. We just have a rough gauge. It is around pH 3 to pH 6. So this yellow region, this is the range of rapid pH change. What I want is I want the indicator working range to be within this yellow region. So you notice what we have. Indicator number 2, my naphtha rate, happens to be within this range of rapid pH change. The working range of my naphtha rate is around 4 to 5 within the range of rapid pH change of this first equivalence point. If I do by color coding, we're just saying that the pink region is within the yellow region. So this will be a suitable indicator for the first equivalence point. Indicator number 2 will be suitable. Now indicator number 1 is not suitable. My thermal blue, it is outside this range, it is not suitable. My neutral rate, it is also not suitable because the working range is again outside this range of rapid pH change at equivalence point number 1. Now how about equivalence point number 2? Range of rapid pH change is around 8 to 11. Again, a rough gauge will do. And you notice indicator number 1, my thermal blue, will be suitable because this blue region, which is the working range of the indicator, it is within this yellow region, the range of rapid pH change at my equivalence point number 2. So I know that my thermal blue will be a suitable indicator for equivalence point 2. So we more or less have determined the indicator that I should use for equivalence point number 1 is naphtha rate. My equivalence point number 2 should be my thermal blue. Then what I can do is I can look at my options A, B, C, D, and I can choose my answer. So you notice A is not true because I'm not using thermal blue for both of them. This is not true. B, in this case, this is the best answer. First indicator, it is my naphtha rate, which we have already determined. Then second indicator, this is my thermal blue, which we have also already determined. So in this case, B will be my best answer. I know that our neutral rate, it is not involved or it is not suitable for either of these equivalence point. So as long as the option contains neutral rate, of course, we will reject that answer. So you notice option C has neutral rate, so we will reject this guy. Option D has neutral rate. Of course, we will also have to reject this option. So very clearly, the answer to this question will be option B. Alright, so that was the discussion involving question 15. So if you have learned something useful from this video, please give me the thumbs up, like this video, and subscribe to my YouTube channel for more weekly video lessons. That's all for now. I'll see you next week.